Hello everybody, my name is Mike LoVullo and I'm a teacher at International Preparatory School. I teach science at International Preparatory School, and today I'm going to share an exciting lesson lab activity called Greenhouse in a Beaker. So you can see behind me here the activity Greenhouse in a Beaker. It actually comes from the NEED project, which is a kind of cool project that I've been involved with. So we're going to do this lab activity today, and this is a lab activity that you could do at home very easily. So I'm going to talk a little bit about, initially about the materials and stuff that you need to do this lab activity. And I'm also going to tell you and give you some tips on, if you wanted to do this at home, because we could alternate some of the materials that you need for it. Okay? So initially here we're going to look at our question. So it's kind of a neat question, right? What effect does adding carbon dioxide to the air have on the air's temperature during the day and during the night? So anytime you're in science, you always have questions that you want to address. Okay, so we have an interesting question here. What's going to happen with carbon dioxide and how is that going to affect the air temperature? So immediately as a scientist, you want to create a hypothesis. Okay, so we're going to create a hypothesis. So looking at this, in your science notebook, you would record your hypothesis. It could be an if-then statement. It doesn't necessarily need to be, okay? But it needs to be a statement telling what you think carbon dioxide is going to do to the air temperature, okay? And you might have some ideas of this because you've heard things before. So that's great, okay? So right now I'm going to go through some of the materials that you need to do a lab activity like this, starting with your safety goggles. So safety goggles are super important when you're working in lab activities and such. At home, maybe you could wear glasses or something just to cover your eyes just in case. This particular lab activity, there aren't too many worries, but having your goggles is super important. So also today we've got two 600 ml beakers. Again, you could just use large cups. So you don't necessarily need two 600 milliliter beakers. You need a 250 milliliter Erlenmeyer flask, with a stopper. And the stopper is unique because it has a hole in it. Okay, so you're going to see why we need that hole in this stopper. So as you use this, you'll see. But again, for the Erlenmeyer flask, you could use any sort of wide mouth bottle that you might have at home. Like I just jotted down, like a Gatorade bottle would work really well, or like an iced tea bottle that has like a wide mouth, that'll work too. So our Erlenmeyer flask, okay, and we got our stopper. Then we've got some vinyl tubing here, and you can get this like even at like fish stores and stuff like that. It's just vinyl tubing. Then we have our clip light. So our clip light is actually attached over here. There's our clip light, which is going to serve as our light source today. Okay? And then next, we have a ruler. So I'm sure everybody's used one of these before, but here's your ruler. So we're going to use that in just a second. Okay? We've got two thermometers. So these are the traditional kind of glass thermometers that we have. But you can very easily, for very cheap, buy digital probe thermometers, super cheap anywhere, like you can go to Walmart or wherever. Okay, so we've got two of those. And then we've got some masking tape, and we've got our Alka-Seltzer tablets. So anybody that has antacid and pain relief, there's your Alka-Seltzer tablets. Some people take these. And then finally, we've got some room temperature water. Okay, so we've got room temperature water that we're going to utilize. All right, so how do we set this up? Well, initially here we have our light source. Okay, so we have our light source set up, and what we're going to do is following the instructions that are here. If I just scroll up here, you'll be able to see on the screen. So there's our procedure. So you're going to see here, you want our light source about 15 centimeters in front of the two beakers. So what we're going to do is just take our ruler, okay? and you're going to measure out 15 centimeters. Now, measurement-wise, remember, so we've got inches and then we've got centimeters. And in science, we always use the metric system, so centimeters. Okay, so we're going to go and we're going to put our beakers approximately 15 centimeters. Doesn't have to be like, exact per se. So approximately 15 centimeters. And our light source is actually in the container a little bit. So let's just put it, let's go right there. Let's adjust this just a little bit. Okay, perfect. We got that set up. All right. Then next up, it says here we're going to insert the tubing through the hole in the 250 milliliter flask. So that's why we have this stopper with the hole. Okay. So this tubing is actually going to go through the hole, which in this case we're going to need to get another type of stopper here because this one will not fit the tubing that's here. So we're going to get a stopper that has a larger hole for our tubing here because that's going to connect into there. All right. So we do need another type of stopper. Okay. So we'll get that in just a second. And in the meantime, we're going to add 120 milliliters of water to the flask. Okay? So we're going to take our water that we have here that we got before, our room temperature water. Okay? And I'm going to throw my goggles on before we start here. All right. And we're going to go down and we're going to measure out approximately 120 mils of water. So here we go. We're at 100. We're at about 120. Perfect. Okay. And again, if you're doing this at home, it doesn't have to be exact. Approximately. Even if you couldn't measure in the metric system, it's really just about a cup of water. Okay. So we've got our 120 mils of water, and then we're going to get our tubing in just a second. We're going to get that hooked up. And what we're going to do is we're going to take our thermometers here and we're going to set them into our beakers. Because initially here, we want to be able to see a stable temperature for each of these before we have any light source on it. Okay? So initially we're going to do that just to get those prepared. Okay? So we've got our thermometers in there, and okay. And what we're going to do now is we're going to turn on our light source in just a second. Let's just check our thermometers. So it looks like this one's reading about 21 degrees Celsius. And let's see if the other one's approximately 21 degrees Celsius. So that one's reading a little bit higher. It's a little bit higher. If it's off by a degree Celsius or 2, that's okay. That's real close. Okay? So what we're going to do is we're going to show you how to continue with this experiment in just a second. And we'll get into how greenhouse in a beaker works. Okay? So stay tuned for us. Welcome back, guys and girls. This is Mike LoVullo from International Preparatory School. I teach science there, and we're just coming back with greenhouse in a beaker. And we left off a few minutes ago, and we had a little glitch, and we came up with a solution. So we're gonna pick up where we left off. Okay, so greenhouse in a beaker. Again, remember we're testing the effect. What does the effect of carbon dioxide to the air have on the air's temperature during day and night? Okay, so again, we were in the midst of kind of putting this experiment together, and we've got our light source, we've got our beakers in place with thermometers, and we were just about to take a look at our Erlenmeyer flask, and we realized our stopper, the the vinyl tubing didn't fit in it, so we made a little makeshift here. So I've got some, it's just some plastic, and I cut a piece of plastic and then kind of poked a hole in it so that our vinyl tubing fits through it. Okay, so we're going to fit that through like that, and then we're going to carefully kind of tape that to there when we're ready. Okay, so what we're going to do right now is we're going to turn on our light source. Okay, so we're getting our light source queued up on our beakers, and we're just kind of making sure that these are lined up right. Okay, so we got our light source going, and what we're going to do is we're going to take our Alka-Seltzer tablet. Okay, so we're going to open this up, and as we open this, you're going to see you got these tabs here. There's one, there's two. Okay, so here's our Alka-Seltzer tabs, and this part's a little bit tricky in that you're going to break them in half, and then right away you're going to put them into your tubing. Okay, so we're going to have to work quick to do this, but we'll make it work. Okay, so I'm going to get some tape off of here and make sure that we have tape to kind of secure that. So we're going to have the tape there. All right, so we've got this. We're going to put our tubing into the beaker here. Okay, so just like that. And we're going to carefully put these into our Erlenmeyer flask. And then, like I said, I'm going to take the tape and wrap it around there quick. So I'm going to make sure I have enough tape here to get that wrapped up nicely. All right. Okay, so here we go. We're going to break that into small pieces, keep it in our hand, just like that. And then we're going to carefully drop it in. And then I'm going to take my tape very quickly and try to seal that off as best we can, which it looks like it's working. Yeah. Okay, now we've got that in here, and I don't know if anybody notices in our Erlenmeyer flask there, what is happening? Whew, we got bubbles, okay? Because that Alka-Seltzer is releasing something right now. And out there, you guys could take a guess as to what it's releasing. But what usually creates bubbles? We know that gases do, okay? And in this case, a particular gas, which we're investigating here, okay? If we go back to the top, we said we're looking at carbon dioxide. So that was releasing carbon dioxide. Now, in our beakers, there's only air. There's nothing in the beaker except the thermometers. So what we're trying to look at here is this tubing here is connected and inserted into this beaker. And what it's going to do is the carbon dioxide that's in here, what do you think? Where's it going to go? It's going to go into the beaker. Okay, so it's going to go through this tubing, and it's going to go into the beaker. Now I'm just going to push that down a little further, make sure we're getting all that carbon dioxide. And what we're going to do is we're going to take a look and gather some data here now on what happens with our temperature as CO2 is added to our beaker over here. And initially here, every 30 seconds, we're going to take a look at this. Okay, and we're going to look at this to gather some data. And when we gather our data, okay, as you can see on the screen, we've got a data table, and we're gonna put our data in here. Okay, so initially was our beginning temperature, and then every 30 seconds, we're going to measure it. Beaker 1 without CO2, that's this right here. And then we've got beaker 2 with the CO2. And we're going to see how carbon dioxide is affecting our temperature. Okay, so initially here, I'm going to take a look here. In our one without carbon dioxide, we're at about 20, we'll call it like 21 degrees Celsius. And in our beaker with carbon dioxide, we're at about 24 degrees Celsius already. Okay, so you got a difference there of what? I mean, 24 to 21. So you got a difference of about 3 degrees Celsius already. Okay, so some way or somehow that carbon dioxide, okay, is heating up. Okay, it's heating up this beaker of air. Now you might say, why, what happens when the carbon dioxide enters that particular beaker? Well, carbon dioxide is actually more dense. Okay, it's more dense than air. So what happens is that carbon dioxide enters the beaker and actually pushes the air out. Okay, so it pushes the air out. And when it does that, you see a higher concentration of carbon dioxide. Okay, so as we go here, we're going to continue to look at and fill out our data so that we can take that data and we'll be able to utilize that data and create a graph of that data. Okay, so we're going to set up a graph of the data to see what's happening there and what are the implications of increased carbon dioxide in the beaker and ultimately in our atmosphere. Okay, so in the next segment, what we're going to do is we're going to take a look and see finally what were our final results as we leave this out for about 3 minutes. That's usually what we go out to. Okay, and we're going to see our results and look at the implications of that and talk a little bit about the greenhouse effect and how the greenhouse effect is being affected by carbon dioxide levels and what that's leading to. Okay, so again, as we take a look, I can see this is almost at 25 degrees Celsius right now. Okay, so it's almost at 25 degrees Celsius. So we know that our carbon dioxide is increasing that temperature. All right, and we're going to see that as we kind of plot out our data and create our graph in the next segment. Okay, so you guys stay tuned and we'll finish up and we'll show you how to graph. Welcome back, guys and girls. This is Mike LoVullo from International Preparatory School, and we're just coming back to you talking again about this idea of greenhouse in a beaker, and we're going to kind of close this up and take a look at some of the results of this and some possible implications of it. Okay, so again, this was greenhouse in a beaker, and we went through and we collected a bunch of data, and we had our data in a data table, and we went and graphed the data. Okay, and we took a look at the graph to see what is going on. And just to quickly recap, we saw in our beaker with carbon dioxide, we saw our temperature rise up. Okay, so our temperature was moving up. So now, what can we make of that? All right, so as we take a look at some of the conclusions to this experiment, first of all, we want to look at our hypothesis and say, hey, was our hypothesis correct or not? And why? Okay, and explain your data to look at your data to explain what happened. Okay, and then, just think about, why do you think this happened? And then finally, how does this demonstration relate to something called climate change? Okay, so we're going to get into a little bit more about that, this idea of the greenhouse effect and how the implications of climate change. Okay, so right now behind me you're going to see pulled up a slideshow, and it's talking about the greenhouse effect. This is a really cool picture, showing carbon dioxide in our atmosphere, water, CH4, which is methane, okay, is another greenhouse gas. So we're going to talk a little bit about the greenhouse effect and greenhouse gases. All right. So first of all, how does it work? Well, greenhouse gases trap heat in the atmosphere. If they did not trap heat in the atmosphere, this would be a very cold planet. It's not a bad thing. Okay, the greenhouse effect is not a bad thing. Greenhouse gas is not a bad thing. They're helping keep in that, that energy for us to keep our planet warm. Okay, so here's in essence the greenhouse effect, how it works. All right, sun shines down, heat is either absorbed or heat is reflected. Okay, it's either absorbed or reflected. Those greenhouse gases affect what's absorbed and what's reflected. Okay, so as you take a look at this and you think about the lab activity we just did, greenhouse in a beaker. Well, there was a bunch of carbon dioxide. The carbon dioxide heated up the atmosphere. Well, think about this. If we have a bunch of carbon dioxide in the atmosphere, our greenhouse effect, what's going to happen with all that heat that's reflected? Is it going to reflect into space, or is it going to be stuck in our atmosphere? Okay, so our greenhouse gases, there's more gases than just carbon dioxide. There's water vapor, there's methane, there's nitrous oxide, there are fluorinated gases, and then finally carbon dioxide, which is our big one that we're going to spend most of the time on. Okay, so water vapor a little bit. It's actually the most abundant, okay, the most abundant greenhouse gas in our atmosphere. All right, so water, water is released through all sorts of different processes, whether you're talking about photosynthesis, okay, or you're talking about our oceans and evaporation. So water vapor is constantly in our atmosphere. Okay, methane and nitrous oxide. So methane is actually a really bad greenhouse gas. Okay, so methane can actually raise the temperature of the earth as well. So methane can be very bad. Nitrous oxide, which that occurs in our soils and stuff. It's a normal process. Fluorinated gases, we don't have to worry about too much anymore. We actually don't use like CFCs and stuff like that have been banned because they were hurting the ozone layer. So we don't have as much worries about fluorinated gases, but carbon dioxide we have worries about. Okay, so carbon dioxide is produced naturally in our atmosphere. It is produced naturally, but here's the caveat. Humankind has altered the natural carbon cycle by burning coal, oil, and natural gas and wood. Okay, so we have added so much carbon dioxide to the atmosphere. And you're going to see that as I show you a very interesting site that you can go to and explore and learn all sorts of things about this, about the greenhouse effect, but also about climate change. Okay, so this depiction here, this graphic here, is just showing the carbon cycle and how carbon is, cycled through our atmosphere from when organisms die. Okay, so those dead organisms and waste products are, they go into the soil and ultimately become fossils and fossil fuels. So when we talk about oil and gas and all, that is all, coming from our through the carbon cycle. Okay, but this is the thing: carbon dioxide was the first greenhouse gas demonstrated to be increasing in our atmospheric concentration. Okay, so I'm going to show you that now. All right, so we're gonna hop out of this, and right now I am going to take you to a site, and this site is called climate.nasa.gov. NASA produces awesome stuff, right? Reputable science science site, organization, done lots of cool things with the world of science. This site is phenomenal, okay? And there's so much stuff that I could show you on this site and share with you, but we would be here forever, and everybody would be like, no. Okay, so NASA.gov climate. First of all, very neat. As you look at this, you can see, and it just switched on me, the site there, but you can actually see satellites. So they show you satellites going around the Earth that are collecting real-time data. So like we collected data in our lab activity. Well, NASA is collecting data constantly on carbon dioxide levels and stuff. So I'm going to show you that now. So if you go up to the top here, so I'm going to go over here, and I am going to go to what's called the vital signs, okay? And the vital signs, the first vital sign that's going to pop up is carbon dioxide, because right now we have a problem with carbon dioxide in our atmosphere, okay? So as you look at this graph, you know, we did some graphing in our lab activity. Look at this graph. What has happened to our carbon dioxide levels? This is only shown from 2007, okay? But you can see our levels now, almost 2020, we're above 410 parts per million. That's the fancy ppm, okay? So that's a unit that we measure carbon dioxide with. But look at that level, okay? I mean, it just keeps going up and up and up. And there's no stop to it if we don't change some of the things that we're doing with carbon dioxide. So you think back at the lab activity, you know, we saw how it's increasing temperature levels. Well, what do you think the other vital signs are? If we look at this, I go back to the top. Here's our other vital signs. Global temperature. Arctic sea ice minimum. So we measure the Arctic sea ice to, we constantly are taking measurements of that to see how are we being affected by this idea of climate change and this idea of too much carbon dioxide. We've got ice sheets and then sea level. The sea level rise thing is scary. It's really scary, okay? So global temperature, if we click on that and we go over here, we can see right here, over here, last annual average anomaly 19.99 degrees Celsius or 1.78 degrees Fahrenheit. So we notice that our temperatures are rising as you look at the graph. Okay? So this is a really cool site, guys and girls. Like, I did not get to show you all that much, but I've used this in my classroom many times. It's a phenomenal site with phenomenal information that you could utilize and just learn about. It's really cool. Okay, so I appreciate you guys watching, and I just want you to stay tuned because there's more to come. Have a great day.